All right. Hello, class. Thanks for joining. Um, Today we are just going to go over some odds and ends for circuits. So I think we should pretty much finish up what we need to know for circuits today, and and then we'll move on to atomic physics tomorrow, I think. So that's my plan. So I wanted to talk today about, first of all, so we're just covering some odds and ends. First thing I wanted to talk about was something called ammeters. Ammeters, they are used to measure current. And the symbol for an ammeter is an A with a circle, like that. Hello, students. Hello, Christian, Jackson, Sam, Sofa, and Aiden. Now, the important thing about an ammeter is that you must place it in series with the device under test. Okay? DUT is just an abbreviation for the device under test, whichever one you're interested in. So, for example, let's suppose I wanted to know what is the current flowing through the 4 ohm resistor. Okay? I would put an ammeter in series with it, like that. What if I wanted to know the current flowing out of the battery? Well, I would put an ammeter in series with the battery. It doesn't matter if you put as long as it's in series. Okay? So I couldn't put the ammeter right here because then it wouldn't be in series with the resistor 4. Okay? What if I wanted to know the current through the 6 ohm resistor? I would put an ammeter in series. So I'm going to put the resistance of an ideal ammeter is 0 ohms. Okay? And the reason for that is as follows. If an ammeter had any resistance, it would change the amount of current that flows through the device under test. So, for example, if this ammeter had resistance, it would mean less current is going to get to resistor 6 because it's adding to the resistance. Okay, so yeah. So that's just a fact that sometimes the IB exam, it asks you, it might be an easy multiple choice question. What's the resistance of an ideal ammeter? Voltmeters, they measure voltage. Also known as they measure potential difference. Symbol for a voltmeter is a V with a circle around it. For voltmeters, you must place in parallel with the device under test. Okay? So if I wanted to measure what is the voltage across this resistor number 3, okay, so I'm back, and I drew a little bit more before I realized that I wasn't broadcasting. But this is how I would get the voltage across resistor number 3. I place it in parallel. This is how I would get the voltage across resistor 1. I place it in parallel. This is how I would get the voltage across resistor 4. I place it in parallel, like so. All right? So you have to place it in parallel. The resistance of an ideal voltmeter is infinity ohms. Infinity ohms. Why is that? Well, you can imagine if this voltmeter doesn't have infinite ohms, then any current that comes out of the battery, and it hits this junction, it has the option of going through the voltmeter or going through the resistor. Now, if the okay, I think I'm back. So at any rate, if the resistance of the voltmeter is not infinite, then it will pull current away from the 1 ohm, the resistor number 1, which will affect the voltage across resistor number 1. Okay? Do they sell it at the store? I'm wondering if you mean voltmeters and ammeters. The answer is yes. You can buy voltmeters and ammeters. Okay, so that's first little odds and ends that you need to know. Another thing you might want to know, because this lesson, this is the IV curve of a resistor, okay? And if we look at the slope of this, the rise is in current, and the run is the run in volts. So rise over run is current over volts, which is 1 over resistance. So if you have an IV curve that's a straight line, the slope of that is 1 over the resistance, okay? So the slope is 1 over R. Any device that has an IV curve that is a straight line through the origin is called an ohmic device. All right? If you have an IV curve that is not a straight line through the origin, so maybe it's a straight line that doesn't go through the origin, for example, or maybe it's just not even a straight line. Maybe it looks like this. Who knows? These are examples of what are called non-ohmic devices. You can still calculate resistance. Resistance is, if I wanted to know what is the resistance at that point, it would just be, you would just again use resistance is volts over current. So you would just take the coordinates of that point. You see it has a you could also get the power of a certain point. If I looked at these coordinates and I saw, oh, the voltage is this and the current is this, I could use P equals I times V. Excellent question. How can current be negative? And current is negative if it's flowing in the opposite direction. So there's some defined direction for positive current flow, and there's a defined direction, and so the opposite of that is negative current flow. Okay. So the last item for circuits are two very important laws for circuits. Okay. So they are called Kirchhoff's laws, and the first law is called Kirchhoff's current law. And so Kirchhoff's current law has to deal with, I have another good question. Can voltage be negative as well? Yes, voltage can be negative as well. So, that would correspond to simply just flipping the battery upside down. So negative voltage just means, again, the battery is trying to push current in the opposite direction. Kirchhoff's current law has to do with a junction of wires. So let's say I have some wires here. Maybe I have 6 wires, maybe 7 wires. Why not? 7 wires. So this is a junction. What Kirchhoff's current law says is the sum of the currents going into a junction has to equal the sum of the currents going out of the junction. Okay? So let's use this as an example. Let's use this as an example here. So Kirchhoff's current law, in case it got cut off, the current flowing into the junction equals the current flowing out of the junction. So let's suppose I have some currents going in. Okay, so maybe this is 3 amps going in. This is 5 amps going in. This is 10 amps going in. This is 1 amp going in. And then I have some currents going out. This is a 8 amp current going out. This is a 4 amp current going out. Okay? And we want to know, what is this unknown current? We've got, well, let's figure out how much current is going into the junction. We've got 3 amps plus 1 amp. So 4 amps plus 10 amps, 14 amps, plus 5 amps is 19 amps. So I have 19 amps going in. And how much do I have going out? I have 8 amps going out, and I have 4 amps going out. So that's 12 amps going out. So you can see that the amount going out is less than the amount coming in. So that means that this unknown current would have to also be going out. Okay. And it would have to have 7 amps. So I think that might have gotten cut off, but I deduced that that would have to be 7 amps of current going out, because that would make the current going in, which is 19, equal to the current going out. Okay? So the next law that we're going to talk about is called Kirchhoff's voltage law. Okay? And Kirchhoff's voltage law says that the sum of the voltage changes around any loop has to equal 0. So let's suppose I have a battery, and I have 2 resistors. Okay. For example, and let's say this is a 12-volt battery. Okay. And then I have a voltmeter right here that's measuring this resistance, or this voltage, excuse me. And maybe this reads out 10 volts. Okay. Now resistors, they sort of use up voltage. Okay, so they're going to have a drop. So and I want to know, what is the voltage drop across this unknown resistor? Okay. So what I would do is I notice I have a 12-volt rise across this battery. So the change is plus 12. And then I go around, so that my loop, by the way, is this circuit. So I have a 12-volt rise, and then I have a 10-volt drop across the resistor. So I have minus 10. And then I have an unknown drop across the other one. And so that all has to equal 0. So that means that the drop across the unknown drop across that resistor would have to be 2 volts. So this is a 2-volt drop. Okay. So that's Kirchhoff's voltage law. And if you take my physics class next year, we use these laws extensively in the second year of physics when we do circuits, but really you just need to know the statement of the laws more or less for this year. So that concludes circuits for us. So your weekly quiz for next week will be on circuits. And thank you for your patience. Thank you for watching. I'll talk to you tomorrow with news on atomic physics. Okay?